All right, guys, we are back. So we're going to dive straight back in. Is that right? With Ricardo, who is going to be talking to us about chaos engineering, why we should all practice breaking things on purpose. So away you go.
Thank you so much for the intro. So this is going to be hopefully a gentle introduction into chaos engineering. The term itself has been around for a little over 10 years, but the actual principles and thinking behind it much, much longer. And so hopefully you'll be able to kind of take away something from this presentation and how you can use it if you work in technology, maybe even if you don't work in technology. Some of the principles are still useful, I think. So hopefully the presentation is moving. You see the next one?
What do we all have in common?
Yes.
Yes.
Okay. So actually, I'm quite open. I'm quite happy for people to open up the mics. Question to everyone: what do all of these four people have in common, or groups of people have in common? Any kind of ideas? Give me some stuff.
They have to deal with emergencies.
Okay, emergencies.
Yeah, same way. They're all managing incidents.
Managing incidents. Anything else?
I feel really thick. Honestly, I'm looking going, I think they're all people. Like, that's all I've got.
Okay, don't worry, that's cool. So this is the purpose of this talk, really, is to help shed some light onto this. So basically, if we look at these groups, and there are more other groups, but these are just the first four that I thought of, is that they share some common characteristics. Okay, the first is that they undergo incredible amounts of training. Okay, and we'll dive deep into the firefighters in a second. But aside from the training, they also are doing continuous practice to make sure that training is kept up to date and that they can understand it. And they're constantly also looking for ways to improve how they operate. And part of that is, as one of the people suggested, is that because they work in dynamic, changing, and sometimes hostile environments that are very difficult to model and predict. So, why is this important? So it's important because for these groups of people, quite often your safety and your lives depend on these people having to save you in the events of these kind of like unplanned or unpredictable incidents. So another question for everyone: how many hours? Actually, first of all, I should ask, because normally when I do this talk, I ask, is there any firefighters in this group? No, I'm guessing no. But actually, interesting enough, when I think the last physical event you did, Alex, at Canterbury University, when we had the ML person from Holiday Extras, there was sat at the back, there was someone wearing a firefighter uniform. So I thought, oh, this is exciting. Maybe there's a firefighter, within this group, but obviously not today. So does anyone want to hazard how many hours a firefighter needs to train before they're allowed to go out onto and deal with a real fire? Any guesses?
500.
Oh, that's a pretty good guess, actually. That's a pretty good guess. It's actually 600 hours, and it might vary from country to country, but 600 hours before a firefighter is allowed to effectively shadow on a real fire. And then after that, 80% of a firefighter's time is spent on continuous training. Okay, and the reason why they do this, okay, is they want to build intuition into the people so that they can react calmly, instinctively, when they are faced with these, unexpected and unpredictable environments. Okay, and this ensures that they can get the best outcome, which for a firefighter is a managed and controlled fire and lots of safe people and no injuries and tragedies. So what has this got to do with technology, and specifically what has chaos engineering and breaking things got to do with firefighting? Well, it turns out that building intuition so we can act kind of more and respond more quickly is really, really important when we're trying to, deal with computer systems that are failing. Which actually, following on from the previous talk, from a user experience perspective, okay, if your website's down and unavailable, that's a pretty bad user experience, right? And so if I dig deeper into that, technology has. So let me just do this, okay. so technology has become, such an important part of how many businesses operate, but yet we still see, lots of failures. So another question to you, how much would you guess in dollars an hour of downtime impacts a business? And this was basically from a study that the ITC did a couple of years ago. How many dollars per hour of outage do you think it costs a business? Any guesses?
Wouldn't that depend on the type of business?
Okay, so the ITC study looked at 3 types of businesses, right? So this is actually the smallest kind of business. So SME businesses.
$5,000 or pounds.
Okay, so the impact, according to ITC, is $100,000 per hour single downtime. Okay, and we'll come into kind of like some of the how they got to that later on. But when we look, at kind of like, so this is actually in 2017. So I did a blog post about this actually. So in 2017, and some of you probably, I'm not mentioning any names here, but there was a mobile provider who I actually happened to use, so I was particularly impacted, had a significant outage, okay? And, 32 million people were left without their cellular phone access for nearly 24 hours. A very big outage in Heathrow cost a major airline over £80 million, according to its CEO. And then, who can forget, right? In 2018, I didn't hear so much last year, but these several high-profile banking failures. Okay, with you can probably picture people not being able to get their money out, or it taking longer to get their clearance. The output of that was that the UK financial regulator was threatening to get involved, okay, if they couldn't improve the availability and reliability of their system. So it's not just financial impact, it's reputational, as well as threat of regulation and imposing new rules which will impact your business. Okay, so this is stuff that these companies are having to deal with, and so tackling these failures is absolutely a critical priority. And this is a kind of a map of if anyone here uses Monzo, this is what their architecture looks like. Okay, and if you think about how cloud native architectures have evolved, okay, this is what a typical cloud native architecture looks like. It's it's very distributed. It's it's difficult to understand without tooling, and it's a far different beast from the old days when we used to have like maybe a web tier, an app tier, and a data tier. You gave servers names, and those kind of applications were easier to troubleshoot when there was problems. When you're dealing with a highly decentralized distributed architecture like this, okay, it's really difficult. And this actually visualization has been done through an open source tool by Netflix called Visceral. And in order to make sense of that when there's a failure, it's really, really difficult. Okay, and so this has led to some underlying principles for cloud native architecture. One of which is eloquently stated by my CTO, Werner Vogels, that failure is a given. Okay, and statistically, when you look at any architecture, there's always going to be something that fails. And I know that I've been working in technology for 30 years, building infrastructure for small companies, medium-sized companies, and big companies. And the one thing, okay, throughout my entire experience of doing that is that no matter how well we engineered solutions, things would always fail. In fact, actually, back in the day when I used to swear on buying just Sun hardware because it was the most reliable, we started then moving from Sun expensive hardware to more kind of like commodity Windows machines, which were much less reliable. Okay, but because the architecture was going into a more distributed manner, actually we were able to get the same levels of availability for our customers. And we talk about the Rolls-Royce versus Volvo solution. So oh. Can you hear me still?
Yeah.
Yeah. Okay. Right. I just heard some beepings. I wasn't sure whether that was someone trying to ping me here. Okay. So with the result, so with this rise of this new cloud native architecture, okay, the web has grown into this increasingly distributed and decentralized environment, okay, and so these random or determining and sort of troubleshooting these random failures has grown difficult, and at the same time, our dependency on these systems has increased. So we need a way of how we can tackle with this. And now I want to introduce an Amazonian who back in the day worked at Amazon, and actually as part of like a sort of a volunteer job, he was also a firefighter. So he was a brilliant software engineer during the day, but he also was doing volunteering, a firefighter, and he wanted to bring this concept that he was doing in his training and fire drills. He wanted to bring that to work, and so he would go around and he would implement what's called game days, which actually we still use today, and we actually run these with customers. And the purpose of these games days was to do two things. The first is to test, train, and prepare our systems, software, and people to be able to respond to these unpredictable and sort of disasters or situations. And secondly, it was to increase the actual application systems we used to have better resiliency by purposely breaking things. Okay, and actually Jesse, he left Amazon and he went on to found Chef, so some of you might actually know the name, and so he was our original master of disaster, and legend has it, and I can't verify this, that he would go around into our data centers and he would pull cables out or cut things here and there just to make sure that that our architecture was being resilient. Now the term chaos, however, came about later and was coined by Netflix. I think in 2009, I might have that wrong, but there or thereabouts. And, they went on to champion chaos engineering because they themselves had encountered some issues which took Netflix down for a number of hours. So it made them start to think, how would they build and architect cloud native architectures, and how would they test and validate that it would work in the event of, these unknown problems. And there's actually a whole session you could do just on how Netflix do this, and there's actually a video and presentation. So if you're interested, then you can Google AWS Netflix chaos and you'll see the videos. It's fascinating stuff. So this thing called chaos engineering is just a way really to build up confidence and intuition that your applications can withstand the failures that will happen. Okay, what chaos engineering is not, okay, and I want to reinforce this point here, is that you're not doing this randomly. Okay, this is, following the same model as we talked about with the firefighters. This is very carefully planned, very carefully orchestrated simulation and training, so that when it does happen, you're prepared. And so you can think of it as a methodology that helps you build that confidence and intuition within your teams. And what we've learned so far in doing this is that there are different steps you need to consider. So I want to now very quickly walk through these. Now, normally we would probably spend about sort of 40 minutes talking through these steps. So I'm just going to go through these, and if you are interested, then you can check out some of the more deeper dive sessions that cover this. So this is the methodology, and we start with what is the steady state. So one of the most important parts of chaos engineering is to understand the behavior of the system in normal conditions, okay? And the reason for that is simple. When we start artificially injecting failure, you want to make sure that you can return to a well-known state and you understand whether the experiment you've been running is no longer interfering and impacting with your normal system behavior, okay? So it's really important to understand and document what your steady state is. Now, the key here is not, as technologists often do, is to focus on the internal attributes of your system, so CPU, memory, etc. Because with a distributed cloud native architecture and scale, those actually are less meaningful, okay? But instead what you need to do is look and measure the output of what ties together these kind of operational metrics and customer experience. So going back to the first session, it's all about the customer experience. Those are the key metrics that you look for, because when you've got hundreds of thousands of servers, measuring CPU or memory is going to have little meaning to what's really important, which is, how is this affecting your customer experience, and how is it impacting your operational metrics? So to give you some examples of what we do, at Amazon, what we do is we look at the kind of number of orders as its steady state metric. So during testing, when delaying a retail website loading in increments of 100 milliseconds, we found that even those small delays would result in substantial and costly drops in revenue. And every 100 milliseconds, I think it is, in load time, the number of orders and the sales dropped by 1%. So, this makes it a really good metric to use for our steady state. So any of the experiments we do, we can then check to see what the impact on the steady state is. And, going back to Netflix, they use this server-side metric called playback starts, which is the number of time that, when you're on Netflix and you're clicking on the remote control, they figured out that more people who are doing that is a signal, a predictable pattern that, fluctuates, and they need to measure. So the more of that happening, the more likely they've got failures in their system. So that's the steady state. So the next step really is defining the experiments that you're going to run. Okay, and we talk about this from the point of view of specific scenario. So if you'll understand your architecture, you will say, what if this system breaks? What if a downstream system becomes slow? What if we completely removed one building that's got stuff in it? What if we cause the network to become unreliable? Those kind of questions. And here, what we do, again, very similar to kind of like in the experience designing, we engage with our broad stakeholders to do kind of divergent, convergent kind of design thinking kind of workshops to understand and build those hypotheses. And we do that because everyone who cares about a system or application has a different opinion and point of view. And so we try and bring those together to kind of form, what the hypothesis is. And actually, back in the day when I used to do this, we used to pick random people, okay, who actually quite often weren't even technical people. And they would always ask us, why am I here? And we would explain the reason why you're here is to ask the questions that we're not asking. So once you've determined your experiments and hypotheses, once you've determined your hypothesis, the next step is actually to create and run experiments. And here the term is where we really start to think about the term failure injection. And there's lots of tools available, open source, commercial, lots of people invent their own. And, there's another, if you're interested in the tooling side of things, there's a whole session we could do. And sometimes when I do this, I do a demo of actually breaking stuff and seeing what happens when it breaks and how it recovers. But as a rule of thumb, what you need to do when you're running experiments is start small to build confidence in your understanding of your system and your application and work up from that. And you want it to try and be as close as possible to production. Initially, this is, where your immutable cloud infrastructure that you built using infrastructure code is really going to help you, because in, a couple of clicks, you can build replicas of your production environments. Okay. You always need to, in your experiments, to define and create an emergency stop that allows you to quickly go back, just in case anything unexpected happens. And you need to make sure that when you have rolled back, you don't touch things where you can corrupt stuff. Now, one of the terms that is quite often associated with this approach is blast radius, and this is what we're trying to do is limit and so reduce the impact of failures so they don't impact other parts of your system. So this is what we talk about when we're talking about blast radius. And one of the purposes of chaos engineering is to help you test that, help you understand what your blast radius for your components are, make changes, retest, and make sure that you've minimized, the blast radius. And a good example of this is the AWS cloud infrastructure, where we have this concept of a region that has different availability zones. We can lose an entire availability zone in a region, and your services, if you've architected them to work across those AZs, will be unaffected. Okay, this is the whole part of designing these systems so that you can limit the blast radius and give these to your customers so that they can build an architect application so they can limit their blast radius as well. So the next step is verify, and this is during this verify stage is where you're going to need to quantify that once you've run the result. Okay, you can understand what the impact has been on your steady state, and this is really, really important. Why, we talked about steady state. You baseline that so you can compare the data. And again, this in itself has got a whole bunch of stuff in it, which I don't have time to cover in this talk. But again, we could talk about this for 45 minutes alone. So the kind of like the final step really is the kind of the improve stage. And this is where you've now run experiments and you need to identify now how you can improve your systems, based on those business metrics and outcomes. And now we use internally at Amazon a number of different mechanisms to do this, such as weekly operational metrics, the way we, assess the impact of these experiments. And then we do postmortems, so which I'm going to talk about, I think, in a minute. And then we decide, should that change make it into production? What was the main kind of findings of a kind of a experiment? Do we understand what went on? What was the impact on blast radius? That kind of thing. So there's a whole bunch of stuff here that's really important, and this feeds into how you then define and improve, and this cycle goes on. So just conscious of time, so I want to move now. That's the kind of the methodology. I want to just now talk about kind of like the takeaways and what and how you can think about sort of chaos engineering. So, do firefighters set buildings on fire so they can see how they all manage? Of course they don't, right? They don't do that. What they do is they simulate and they train. And chaos engineering is not about deliberately breaking things. So I know, Alex, I forgot to ask you to change the title of the talk. So we used to talk. It's all right. We used to talk about why breaking why you should practice breaking things deliberately on purpose. But as it turns out, from a cultural perspective, that scares the bejesus out of everyone, right? So now we're a bit more gentle because there's a big cultural element here around making sure people understand why this isn't so important. So chaos engineering is not about deliberately breaking things, but just like the firefighters or the RNLI or even the travel attendants on planes that do through the safety briefing at the beginning, or special forces. I had a friend when I was young. I worked with her, and her brother was one of these people you can't ask anything about their job. He disappears for 10 months of the year all over the world, but if there's a hostage situation, he's the one that comes in and rescues you. Right. So, practicing, breaking systems on purpose, like those groups of people, will actually help you understand the weaknesses in your system, will give your people, your staff, better understanding of how those systems work, will help you understand how to address any weaknesses, but also critically give them confidence to quickly resolve issues when they come. Now, and the important thing here is it's about doing this in your business hours, because when you've got all the resources and all your engineers in the room and everyone's wide awake, it's really easy to test and manage this, okay? But, what a lot of people do, okay, and maybe some people on this call will have experienced this quite often, and certainly this is in my early days of building infrastructure. We get outages on a Friday at 9 p.m. where most of us are just about to go out to the pub. Okay, so we're trying to move away from that. We're trying to make sure that we can do all that training, understand our system, so that we don't have as much of those incidents. And again, why is this so important? When we put it into perspective, being a customer obsessed organization as we are as Amazon, our customers have seen the benefits of us doing this with fewer downtime hours. And this is despite, the fact that we're still releasing thousands of new features and services every year. So this is not either or discussion, right? You don't have to, have operational excellence and do chaos engineering and stop doing all your feature designs. This allows you to do both, okay? And so how do you start? Oh, I've got an animation on this. I don't like animations. So how do I do animations? I don't know how to, oh, there you go. I should have taken that off. I didn't, so apologies. So how do you start? So to be successful, you need to successfully manage these three components, okay, to raise the bar in managing your systems. The first is you need to have the right culture, because this is about people. Okay. Second, you need to have great tools. And thirdly, you need to have mechanisms and processes so that you can continuously improve and maintain that standard, okay, and increase that over time. And it's important to understand that whilst there are lots of tooling out there, it's unlikely that you'll be successful if you only focus on the technology, okay? Technology itself is not going to make your systems resilient, okay? People will. You know, and you know, a good example of the cultural challenges is that if you do actually call this chaos engineering, you scare people away. You know, I've been in conversations with financial services companies who are, you know, want to adopt the practices of chaos engineering, but don't, you know, they struggle to sell that internally because of the name. So we now, you know, we talk about operational excellence, building resiliency. It's about understanding your stakeholders, because ultimately, you know, the outcome we're trying to achieve, okay, is to build better, more resilient systems. And so those banking outages that we had last year go away. So the challenges, so this is one of my colleagues in my team, Adrian, who is, you know, our chaos engineering expert. So I encourage all of you to follow him if you want to know more. This is a quote from him, just re-emphasizing really that this is, you know, an important thing, but it extends through all those three components. So if you're interested and want to do more and want to know more, read more, learn more, then first of all, as I mentioned, follow Adrian, read his blog. A couple of weeks ago, he posted on the blog, the AWS open source blog, a great post around how Amazon Prime Video is adopting and using these principles to make you know, that service more resilient for our customers. Another resource as well that's really, really useful is the Amazon Builders Library, which is where we share our expertise and experience of building these resilient systems, so you can do this yourself, okay? And then finally, okay, I want to leave you with this message by Benjamin Franklin: by failing to prepare, you are preparing to fail. You know, if your digital systems applications are critical to your business, how are you preparing for failure? So thank you very much for your time. I'm not sure how I did for time, Alex, whether I'm over or under, but I'm opening up to questions.
Yeah, I think you're about, yeah, a little bit over actually, but that's not a problem. So yeah, has anyone got any questions?
Yeah, that was really fascinating, Ricardo. I think I really, really enjoyed that. And I was struck by the similarity of your chaos engineering, you know, benchmark, come up with the design hypothesis, do the testing or validate, and then feed that into the next iterative cycle. But my question really is, I mean, you mentioned it's not either or, it's not chaos engineering or doing your kind of normal product and feature releasing. How on earth do you manage that across an organization the size of Amazon, or even just the AWS bit of Amazon? You know, there's product managers, product teams coming up with features, services, whatever. They've all got their release schedules, and you're, you know, trying to do your chaos engineering bit and make sure it's resilient and maybe occasionally breaking stuff. How do you synchronize all of that?
So it comes to, you know, the three things I talked about. Okay, the kind of the main driver for that is our cultural, levers, right? So Amazon, we have leadership principles. So everyone that's hired into Amazon has these 14 leadership principles that they aspire to, and that's a key piece of it, right? So we're all owners. We all take ownership of what we're building. So you know, setting the right culture at an individual level. Within teams themselves, operational excellence within AWS, but also across Amazon. After security, operational excellence is our #1 priority. And we will actually, if a service isn't performing as well as it should be in the eyes of our customer, we will refocus our efforts on making sure that it is at the level it should be before continuing. So a lot of this is to do with leadership. I talked about very quickly about the weekly reviews. The weekly reviews actually are still attended by the senior leaders within AWS. So Andy Jassy, Charlie Bell, these people attend these weekly ops review meetings, okay? Now, that sends a strong message within the organization that this is important, okay? We have you know, tens of thousands of these small teams, okay? So how do you make sure that you focus, or, you know, that all these teams are focusing? We have this thing called the spinning wheel of fortune, okay? What happens is that in the weekly review, they'll spin the wheel and a service will get chosen, and that team will have to do the review of their operational metrics. Now, what that means is that you don't know going into that meeting whether you're going to be the team that's chosen. But what it means, though, is that every team goes to that prepared, because you do not want to be presenting to our leaders not having the information that they might pick up. And I've been on a call, because these are done remotely, where the senior leaders were looking at some of the op metrics, and they said, look, this graph here doesn't look right. Explain what this is about, okay? And the product manager had to then do a deep dive and explain this is the situation. And then we went through the standard process that we have internally to then understand, is this right? What do we need to do? What's the next steps? That kind of thing. So I think, we do it through more cultural levers than anything else.
Okay, thank you. So it's not someone sat somewhere with a big spreadsheet trying to track all the all the features and all the time.
No, we are a very decentralized organization. We're like a federations of tens of thousands of small little groups, okay? But what keeps us all humming and aligned is this culture and these leadership principles that really focus us on customers, really focus us on making sure that we deliver the best experiences for customers.
Thank you.
So I don't know what I just did there. Thank you. Anyone else got any other questions?
Oh, so there's something in the chat actually.
Oh, one time I don't look at the chat.
Oh, that's all right. That's all right. Okay, it's all right. Sorry, I didn't introduce myself, did I?
No. Oh, that was me. Yeah.
So yeah. Ricardo Sueiras is I'm a principal advocate for open source. I'm Spanish by nationality, but as you can tell from the accent, I've lived in this country for more years than I can remember.
Yeah. So I basically I think I've had this before when I did talk to you before. I think I pronounced your name wrong, and people always do that with mine. So it's like, no, I'm not going to be that person.
We have had this conversation, Alex.
Yeah, I thought we had.
Yeah.
So have we got any other questions?
Do you find when you speak to other organisations about it that you get like pushback in terms of them actually putting the time in to be able to sort of go into these sort of experiments to method the system?
Sorry, I didn't quite. I'm not sure if it's just me, my audio. It's very, very quiet.
I couldn't hear him either. Can you say that again?
Like when you speak to other businesses about chaos engineering and looking at the amount of time that it takes to effectively have a team go in and do that when they're going through that process. Do you find that they kind of look at the amount of time involved in it and are a bit more reluctant to spend the time doing that, as opposed to putting that resource maybe into putting newer features?
So it depends, really. I mean, it's one of the hot topics, right? If I was to look at the requests we get from customers of all sizes in all segments, right? This is something that we get asked a lot, and the reason for that is, as I mentioned, okay, it's never been more important that if you've got a digital business, that your digital business is up and running. Because just imagine if you were a shop, okay, on the high street, and someone basically bricked up your door to not let customers in, okay, and they did that on a regular basis. It has a big impact, right? It has a big impact on the fact that your customers can't do what they want to do. It has a big impact on earning trust with your customers. That I think businesses are waking up to the fact that this thing called IT is important, and they need to start bringing in these kind of like these mature principles in actually how to build it. Now, one of the good things, okay, is that because there's cloud providers like AWS, and obviously we're not the only cloud provider, there's other ones you can use if you prefer those. We take a lot of the hard stuff away from building these resilient systems, which means that, we make it much easier for you to build these resilient systems. So, and as applications are architected to use these higher order services, these businesses can focus less on the chaos engineering side of things, or they still have to do it, but they have to worry less about a lot of the stuff they need to do. Right, so it is a conversation that it's hard for some of these businesses to do. I think from the point of view of the conversation as to, you know, doing this versus releasing new features, that's down to the business, right? That's down to their priorities. You know, do they want to release new features that are unreliable, therefore customers won't use? I don't know, right? But that's the trade-off you will have to make. So yeah, I'm not sure if that answers your question.
Yeah, that pretty much covers it. Thanks.
Yeah, it's a really interesting point you just raised there about, you know, bricking up a storefront. I was trying to book a hotel room on the Travelodge website earlier, and I kept hitting the submit button, and I got the little spinner. Nothing happens. Checked the form fields; they wasn't showing any error messages. I forgot anything. Did it again. So I thought, okay, maybe their back end's screwy. I downloaded the app. So I downloaded the app. According to the app, the hotel that I was trying to book on their website didn't exist in Oswestry in Shropshire. So it's a really, really horrible experience. Their web interface didn't work, and their app didn't apparently have one of their hotels in it. Yeah, so, you know, if it's up there, it's got to work.
I know, it's funny actually. I've had that same experience with Travelodge actually. We were my wife goes to London to do this yoga training, okay, and there's this one hotel she always books, but we couldn't find it through the search mechanism. We had to use it we had to go through it through a bookmark or something. So yeah, so I actually know exactly what you mean.
It's just so bizarre. I mean, their own app doesn't have apparently one of their hotels in it in Oswestry. I've no idea why. No error messages, no nothing.
Ricardo, just out of interest, you mentioned you spoke very heavily about software management.
Tom, your mic's breaking up a lot.
Sorry, let me just try.
If not, you can type it in the chat, and I'll.
There we go. How about that?
With echoey and feedbacky.
Try that again.
Just
Like, you know, Jesus.
Like you're in a horror film.
there we go. Sorry about that. So I've got now. I'm connected on the
perfect.
and the laptop.
That's better.
Okay.
Yeah. So you said about, obviously it focuses quite heavily on software engineering. Do you apply the same principles to your business processes as well?
So they're kind of like that's why I mentioned the steady state, right? They're not, you can't think of this as technology, right? We don't measure steady state in terms of technology. We measure it in terms of business outcomes, right? So, you know, how many orders we can process in a fulfillment center, okay, is an important and valuable metric. And if there's an impact in technology, let's say we introduce a new version of a software, as I said, and we increase the latency by 100 milliseconds. That's a 1% impact on our operating costs, right? So it's really important that you make sure that the business is absolutely at the heart of this. You're not really doing it right unless you're doing that, because you won't have the right steady state metrics. So Netflix use their SPS, which is basically frustrated people clicking on their remotes. We have hundreds of these things, right? That's just one I can talk about. But successful businesses that do this have a business metric or an outcome that they're looking to measure and is their baseline, and they use that as the basis of whether they're improving their resiliency or whether they're going backwards.
Good point, because I think a lot of companies measure the wrong thing a lot of the time, you know, and don't really look at outcomes. They measure, I call them vanity metrics. I think that's what the phrase is. So, you know, they're looking from a technology perspective. They might measure whether a function takes longer to run, whatever. But what is the outcome on the customer or on the business? And that's what's more important. But we do seem to, as an industry, capture the wrong metrics.
Yep.
You know, I work in security, and I was talking to someone today about, you know, it seems to be within the higher echelons of the company. They want to know how many vulnerabilities we have. I actually want to know how many, you know, how secure is our customer data, and what's the impact on our customer if we're not secure, you know, and how do we measure that? That's what's more important than how many vulnerabilities we have. You know, so this is, yeah, this is a good point, and I think outcomes is the key, is that measuring outcomes, not measuring outputs.
Yeah.
Okay, anyone else? No. Okay, right. Thank you.
Is that a wrap?
Yeah, I think so. Yep. Yeah, and just double check the chat. But I think that, yeah, that's everyone. Okay, right.
Well, thanks for having me, Alex.
Yeah, fantastic. I really enjoyed that. Thank you.
Oh, I'm glad. And yeah, hopefully next time we'll be back in the land of the living. Also, obviously, yeah, hopefully next year this might all go back to normal. We'll see.
Whatever normal is.
Cool.
Yeah.
Thank you. Have a great evening.
Yeah. Hopefully
Yeah.
next time we'll get to have pizza with us.
Take care, everyone.
Yeah. Oh, yeah. So I just want to say a quick bye to everyone. So thank you to Ian Westbrook and Ricardo. And basically, thank you to everyone who joined in. And yeah, sorry to people that weren't able to get logged in. Yeah, that was awesome. Right, I'm just going to...
Cool.
Oh, thanks. Oh, thank you. Right. Yeah, shall we...
Bye.
Yeah, guess we'll... Oh,
Yeah.
call it a night then. Right, bye, everyone.
Bye.
Bye, everybody.